Continuing from previous lesson, let's solve few more equations which are reducible to quadratic form. Here we have a question. So let's solve this question. Given example is x plus 1 times x plus 2 times x plus 3 times x plus 4 equal to 24. Now we are going to regroup them in two groups in such a way that sum of constants in one group is equal to sum of constants in the other group. So the first group will be x plus 1 into x plus 4 because 1 plus 4 is equal to 5, and in second group we have x plus 2 times x plus 3 equal to 24. And now if we multiply these factors within each group, what we have is x squared plus 4x plus x plus 4 into x squared plus 2x plus 3x plus 6 equal to 24, and upon simplification we have x squared plus 5x plus 4 into x squared plus 5x plus 6 equal to 24. Like before, let's assume x squared plus 5x equal to y. This leaves us with the equation y plus 4 times y plus 6 equal to 24, which is a quadratic equation in y, which is quadratic in y. Now we will use ordinary methods which we use for solving quadratic equations. Let's standardize it, and this will give us y squared plus 10y plus 24 equal to 24, leaving behind y squared plus 10y equal to 0. If we take y common, this leaves us y plus 10 equal to 0. So y is either equal to 0 or y is equal to minus 10. Initially y was equal to x squared plus 5x, so replacing y equal to x squared plus 5x, we have x squared plus 5x equal to 0, and on this side we have x squared plus 5x equal to minus 10. And now we will solve these quadratic equations, which will result in 4 values of x, and that will be our required solution. Taking x common, x plus 5 equal to 0, or x equal to 0, or x equal to minus 5. And on this side here we are going to apply quadratic formula, but before that we will standardize this. X squared plus 5x plus 10 equal to 0. Here a equal to 1, b equal to 5, and c equal to 10. And using quadratic formula, we have x equal to minus b plus minus b square minus 4ac divided by 2a. That will give us minus 5 plus minus b square will be like 25 minus 4 times a is 1 and c is equal to 10. So this is divided by 2a means 2 times 1. This gives us minus 5 plus minus 25 minus 40 divided by 2, and result would be minus 5 plus minus minus 15 square root divided by 2. So because minus 5 plus minus, this could be written as 15 under root time under root minus 1 divided by 2. Minus 1 under root is equal to iota, which is a complex number. It's not a real number. Therefore, we will have the solution for this part as minus 5 plus minus under root 15 iota divided by 2. So the solution set. So the solution set is equal to all these 4 values, and what were the values? 0 and minus 5. 0 minus 5 minus 5 plus under root 15 iota divided by 2, and minus 5 minus under root 15 iota divided by 2. So this is the solution set. If we take a look on the next question, which is essentially same but a little difference there, example 2. The given equation is x plus 1 times 2x plus 3, 2x plus 3 into 2x plus 5 into x plus 2 equal to 9, 4, 5. This question is exactly similar to the ones we did before. There is only one difference that I would like to explain, that here the coefficient of x is 2 here and this coefficient of x is 2 here, while in the standard form there was no coefficient of x. In order to get rid of this coefficient 2 here and 2 on the other side, let us divide both sides by 4. Like 2 on this side, 2, and we divide this side by 2, and here we divide again by 2 and we divide with 2 one more time. So this gives us x plus 1 times x plus 3 over 2 into x plus 5 over 2 into x plus 2. This will help us 9, 4, 5 divided by 4. This is going to help us which two factors are grouped together and the other two factors grouped together in a separate group. Here we are going to regroup x plus 1, this x plus 1 and this one, because the sum of constants, since, let's write this down, 1 plus 5 by 2 is equal to 7 by 2, and the sum of other two constants, which is 2 plus 3 by 2 is also 7 by 2. Therefore, the grouping will be done like this. So if we make the groups, this would be x plus 1 time x plus 5 by 2 into x plus 3 by 2 into x plus 2, and this group will stay separate with this group equal to 9, 4, 5 divided by 4. Now once the grouping is done, we can multiply that 4 back into this groups where we got that 4 from. So if we multiply 2 here, this will give us x plus 1 into 2x plus 5, and if we multiply 2 on this side here, this will give us 2x plus 3 into x plus 2. This was this divided and multiplied 4 just to make sure that our groups are rightly grouped together. So 9, 4, 5, and rest is obviously same. We are going to multiply this like x square 2x square plus 5x plus 2x plus 5 into 2x square plus 4x plus 3x plus 6 equal to 9, 4, 5, and upon simplification we'll have 2x square plus 5x plus 2x, that will become 7x, so that will be plus 7x plus 5 into 2x square plus 7x plus 6 equal to 9, 4, 5. Let 2x square plus 7x be equal to y. This will give us y plus 5 times y plus 6, y plus 6 equal to 9, 4, 5, which is quadratic equation in y, which is quadratic equation in y. I hope you can continue this question now by multiplying y plus 5 with y plus 6 and then standardizing it, then solving this quadratic equation by using either factor or by quadratic method, or completing the square, getting the two roots, and then substituting the value of y and doing the solution just we did for 2 questions before. But doing this question up to this point, the intent was that you know how to group factors together when the coefficient of x is other than 1. And I'll do briefly one more question just to illustrate the initial procedure, example 3. And in this, the given equation is solve the equation. What is this? This is x square plus 6x plus 8, x square plus 6x plus 8 time x square plus 14 x plus 48 equal to 105. Now what to do? In fact, we always had 4 factors, and out of 4 factors we used to group them together and make 2 groups in such a way that this part, the first 2, and this part were essentially same. But we have these two groups, but the first two terms are not same. Therefore, we are going to factorize each of these expressions, and then we will regroup them so that the sum of constants in one group is equal to sum of constants in the other group. So let's get started, and we will factorize. For factorization, this would be x squared plus, because a is 1 in the first one and c is 8 and their product is plus 8. So we should find two such factors of 8 whose sum is equal to 6, which is 2 plus 4. X plus 8, so that is first group, and in the second one we have x squared plus 6 plus 8. These are also factors of 48, plus 48 equal to 105, and x squared plus 2x plus 4x plus 8 in this group, and in this group you will have x squared plus 6x plus 8x plus 48 is equal to 105. Now this will become, if we take x common, x plus 2, and we take common plus 4, we get x plus 2 again, and in the second group we take x common, x plus 6 plus 8 common, and x plus 6 again equal to 105. And now let's take common. We will have in this group here x plus 2 times x plus 4 into x plus 6 times x plus 8 equal to 105. And now we have four factors: x plus 2, x plus 4 into x plus 6 into x plus 8 equal to 105. Now regrouping will take place. Regrouping. And in this regrouping, we are going to take two factors together so that the sum of constants is same in both groups, which can only be possible if we combine x plus 2 with x plus 8 and x plus 4 times x plus 6 equal to 105. And now we have this as x squared plus 10x plus 16 times x squared plus 10x plus 24 equal to 105. And now you can see it's x squared plus 10x on this side and x squared plus 10x on this side. So we can assume x squared plus 10x equal to y. This will give us y plus 16 times y plus 24 equal to 105, which is a quadratic equation in y, which is quadratic equation in y. Now you can multiply, standardize it, solve it, and then replace value of y by x squared plus 10x again. We believe that you are well on your way to solve this question. Good luck and see you in next lesson with new questions.